Hello and welcome to the Chemistry Academy. In this video we're going to go over reactions of metals in relation to the National 5 chemistry course. So when it comes to reactions of metals, you need to know what substances different metals can react with and what is produced when they do react with those substances. So the three substances you tend to look at are reaction with oxygen, reaction with acid and reaction with water. So if we start off with looking at reaction with oxygen, now metals that are extremely unreactive are the only ones that won't react with oxygen. So the metals that you tend to find uncombined, if you remember from my metals and extracting metals video when we talked about ores, those metals that can be found uncombined, where they're just sat in the ground on their own, they tend to not react with oxygen. So that would be your gold, your mercury, and sometimes also silver. Silver is one of the ones that sometimes will react with oxygen. It depends how warm the conditions are, etc. But when it comes to metals that don't react with oxygen, you can use the electrochemical series in your data booklet to help you. And the least reactive metals are down at the bottom. So if you are asked a question about which of these metals is least likely to react with oxygen, you'd want to look for the one that's furthest down the electrochemical series. The reaction with oxygen is pretty straightforward because when a metal reacts with oxygen, all that's formed is a metal oxide. So got an example here is if you've got copper metal just sat outside, it can react with oxygen in the air and it ends up forming copper oxide. Now, interesting story. The Statue of Liberty, she was made of copper, so she used to be brown, but because she's been sat outside for so many years exposed to oxygen, the surface of her has actually turned into copper oxide, which gives her her greeny blue colour. So if we were to strip all the copper oxide off the Statue of Liberty, she would actually be copper coloured underneath. So the surface of her, because it's been exposed to oxygen, has turned into copper oxide and it has a different colour than the original copper had. So that's the reaction with oxygen, very straightforward. The metal reacts with oxygen to form a metal oxide. If we then look at reactions with acid, so the metals that will react with acid are the ones that are above hydrogen in the electrochemical series. So again, the electrochemical series is very useful when looking at reactivity of metals. So if you're looking for one that will react with an acid, it needs to be above hydrogen in the electrochemical series. If you want one that won't react with an acid, then you need to look below hydrogen in that electrochemical series. So the hydrogen's just in there as a marker, really. So when we react a metal with an acid, we end up making a salt, but we don't make water like in a neutralisation reaction, we make hydrogen gas. So if we take the example of aluminium metal, aluminium is above hydrogen in the electrochemical series, so that means it can react with an acid. So if we react aluminium with hydrochloric acid, we would end up making aluminium chloride salt, which is a soluble salt, so it would be aqueous. And then we also produce our hydrogen gas. You may have been shown this experiment in class potentially, and you can prove that it's hydrogen gas that's produced and not any other gas by doing the chemical test for hydrogen, which hopefully you remember is that it burns with a pop. So if you were to take a lit wooden splint and put it in the mouth of the test tube that you're doing your reaction in, it should make a wee pop noise. So don't forget, the test for hydrogen is that it burns with a pop. So then on to reaction with water. So it's only really the group 1 and 2 metals that will react with water, so the alkali metals and the alkali earth metals. If the conditions are warm enough, you might potentially get any of the group 3 metals to react with water, but generally, as a general rule, in your National 5 chemistry exam, we tend to just say that it's the group 1 and group 2 metals that will react with water. When a metal reacts with water, you end up making a metal hydroxide. So the water molecule splits up into the ions that we learned about in the acids and bases topic, hydrogen and hydroxide. The hydroxide ion attaches to the metal because the metal will end up as a positive ion when it reacts and opposites attract, and the hydrogen ions just pair up with each other to make hydrogen gas. So again, you could test that you were actually producing hydrogen gas by taking your lit splint and it would burn with a pop. I won't make the pop noise again. So that's how that works. So if like I've got here the example of calcium solid, putting it into water, you'd end up making calcium hydroxide solution, and then your hydrogen gas would be given off. So you would see some bubbles or effervescence, if you like. In relation to the group 1 and group 2 metals and their reactivity, especially with water, group 1 is more reactive than group 2. And as you go down either of the groups, the reactivity increases. So as you go down group 1, the metals get progressively more reactive. Some of you might remember seeing the Brainiac alkali metals video when you were in school, where they put some of the more reactive alkali metals in bathtubs of water. They got as far down as cesium, and then francium you aren't actually allowed to do it with because it's far too reactive to even be safe in terms of how they did it in an outdoor area, etc. So as you go down the group, it gets more reactive. Because the group 1 metals are so reactive with water, they need to be stored in oil or a noble gas atmosphere. So you might have learned that in Unit 1 as well when you were looking at the periodic table. But it's just to remind you of that at this point in time, because we are obviously talking about the reactivity of metals. So the reason they get stored in oil or a noble gas atmosphere is to prevent them from reacting with water, specifically in the air. It can also be to prevent them reacting with oxygen, but it's the reaction with water that's the more explosive one for the alkali metals. So we want to avoid that from happening. So that's essentially it really for the reactivity of metals. Like I said, you really just need to remember what's produced when you react the different metals and which of these 3 substances the different metals will react with. In your exams and tests, you might also be given information as well on a certain metal and whether it can react or not, and be asked to suggest which metal it could be or place them in order of reactivity. So we'll do a wee example on that just before we finish, and then that'll be us for this video. So just to finish off here, we're going to look at one of these example questions that I mentioned earlier. So we're given a table of experimental data or information, and we're asked to put the metals in order of increasing reactivity. Now sometimes this can be increasing reactivity, decreasing reactivity, so it's very important that you make a note to yourself of what order of reactivity you're asked to put the metals in. Because we're asked for order of increasing reactivity, that means we're going to be starting with the lowest in reactivity, going up to the highest in reactivity. So if we look at the data that we've got here, we can see that we've just got arbitrary metals, so they're not named, they're just called X, Y and Z. And we can see how they react with oxygen, acid and water like we've looked at already. So the first place to look usually is whether it reacts with oxygen or not, because if a metal's not reacting with oxygen, it means it's really not very reactive. So we can see that metal X does not react with oxygen, which means it must be very unreactive. Something like gold or silver that we would use for jewellery is not going to get reacted when exposed to oxygen. So we would then place X as our lowest in reactivity because it's not even reacting with oxygen. If we then go and look at the reaction with water, that can also be the next best place to go, because if a metal's reacting with water, it tends to be pretty reactive. So we can see that the only metal that's reacting with water is metal Y. So that's going to be our most reactive one, because like I said, if a metal is reacting with water, it's probably pretty reactive. That leaves Z in the middle, which makes sense because when we compare the reaction with acid, it only has a moderate reaction with acid rather than a fast one, which indicates it's less reactive than Y as well. So our Z would be in the middle. To take this a step further, which you could potentially be asked to do, would be to suggest a metal that could be each of these different ones. So if we're looking for X, we are looking for a metal that doesn't react with oxygen, so that would be one of the lower down metals. So that could be like gold or mercury or even potentially silver, but gold's usually the safe one to go with. If we're looking for what Z could be, so Z could react with oxygen, it can react with acid, but it won't react with water. So that means it has to be above hydrogen in the electrochemical series, but it can't be in group 1 or group 2. So we probably want to go with something like zinc or iron, but we'll just go with zinc. And then for the highest reactivity, this is a metal that will react with oxygen, will react with acid, and it will also react slowly with water. Remember, so that means if it's going to react with water, it needs to be either in group 1 or group 2. But remember, group 1 metals are very reactive with water, so it's most likely going to be a group 2 metal if it's a slow reaction with water. So we'll just pick one like calcium. Okay, so that's how you can kind of use the reactivity of metals to place them in order of reactivity and also suggest what metals could be which based on how they react with different things. So feel free to jot some of these things down into your data booklet on the electrochemical series page. Sometimes it's a good idea to, above hydrogen, just make a note for yourself that any of those metals will react with acids, and then make a note down the bottom that the lower down metals are the least reactive ones. Just so while you're studying and doing your homework and things, it's there on your data booklet for you to be reminded of often. And also don't forget that hydrogen burns with a pop. So if you find this useful, please give it a like and don't forget to subscribe, and I'll see you again soon.